So I'm going to show the whole video from start to finish of how we put the titanium sheet in the bar and how it turned out. So just stay watching and listen and learn. Actually, what is titanium and why are we interested in it? It's actually a really interesting and useful engineering material. It's a metallic, obviously. It's in the elemental form, one of the 5 most abundant metals found on Earth. In Earth, it's usually found in its ore. The ores can be rutile, ilmenite, or perovskite. And so usually you have to do some processing to the ore to retrieve the metal from it. In titanium's case, for engineering purposes, we use a carbochlorination process called the Kroll process. That is taking the ore, heating it up in a big vessel called a chlorinator, and then with chlorine gas and powdered coal that we call coke, producing titanium tetrachloride. The titanium tetrachloride is then reduced with liquid magnesium to produce magnesium chloride and solid titanium. The solid titanium then has to be distilled a couple of times to remove all the excess mag chloride and unreacted liquid mag. Then finally, it's crushed when it's in the solid form of sponge and mixed in with other elements like aluminium, vanadium, and so on, which you call master alloys, to get your different alloys that you need, like Ti-6-4, which is actually an alpha beta alloy that's the most common engineering version of titanium I think that is around today. So for producing aircraft parts, let's say, or engine parts, you would have to triple melt an ingot and then produce from that forgings, castings. You can roll to sheet and plate and so on. You can also use double melt if it's a standard product, which could be some structural stuff. And then for other instances, you could also use electron beam to melt if you don't use VAR, which is vacuum arc remelt. You can also use plasma for melting in certain circumstances, but each one has its pros and cons, and each one has its advantages, disadvantages, and specific uses. So in the case of titanium sheet, for the architectural stuff, there's different finishes and sort of lusters you can apply using heat treatment, things like anodizing. For example, here is a titanium headband that actually Gary made for me when I was trying to cosplay Lieutenant Valeris from Star Trek VI, The Undiscovered Country. Don't know if you remember that one, but Kim Cattrall had a metal headband made for her hair in that one, but hers was made out of aluminium. I thought, well, that's lame. Let's make a titanium one. So as far as I know, this is the only titanium headband in existence that is not only anodized, so it's actually different colors, but it also has this grain structure, which we call crystal titanium, and it's very attractive. It's usually in engineering materials, people are interested in small grain size for higher strength because there's an inverse relationship called the Hall-Petch equation, which relates grain size to strength. But for the architectural and decorative stuff, we don't really care about doing any load bearing. So we can afford to heat the grains up, polish the sheet so that it looks nice, and then you can apply different finishes like anodizing and so on. Here it's been formed and then anodized, so that's really nice for, I just don't have the pointed ears right now, but if you go back and watch Star Trek VI, The Undiscovered Country, that's my version of the headband from Lieutenant Valeris. So architectural titanium can be seen in structures literally all over the world, from the Van Gogh Museum in Amsterdam to the airport in Dubai to the Guggenheim Museum in Bilbao, the Denver Art Museum, loads of private residences in office buildings in Japan, private residences in Palos Verdes, California, in Scandinavia, and yeah, pretty much anywhere you go, if you find a futuristic building that's covered in metal sheet, it's probably one of Gary's projects. So here is the bar as it looks today, and as you can see, it's a pretty plain background. I'm going to transform this. It's also unfortunately become a dumping ground for a few things, the coffee maker and the blender and whatnot, so I'll try and get rid of this. Let's see if we can do this. So first, let's start off by laying out the entire area and just looking at this wall. It's completely dry and clean, of course. And then measuring all the sort of T-shape, if you like, of the wall to translate into a plan which Gary has laid out for me, and cut these sheets according to a kind of jigsaw puzzle plan. And I'm going to put all that together following his instructions. What he's done is actually labeled the back of each sheet so that I know which one goes where. For example, this is B and it will be in this direction. So B is going to be right here on this plan, and that's going to translate to roughly about here on the T-shape. So let's move to the next step, which is getting the adhesive. So what we've done now is we have fitted up dry the sheets to the wall, and we just used some masking tape to hold it in place temporarily. But what we found is that 2 sheets actually can't fit in this gap. And the reason is that when the cabinet was installed, there is a piece of plastic which holds the cabinet up to the wall, and that is just blocking the sheets from sliding in this gap here, which is very unfortunate. If we look at the cabinet on this side, I can see that that piece of plastic is just raised up like maybe a 1/16 of an inch. And so these sheets, which are identical in size, actually can fit underneath here. So it just happens to be a fluke of cabinet making, and didn't realize that at the time. So that's the reason that we did this dry fit, is just to make sure that the pieces fit, and so they don't. So plan B, we could either take these sheets to another machine shop here in Vegas and get them sheared, but we'd have to wait another day for that. Or we could try to cut a slot in this piece of plastic where it actually impedes the sheet from sliding under the cabinet. And so we're going to see if just using a small vibratory tool with a saw can take out a tiny, because that's really like all this needs to be, is just a tiny piece of plastic being removed. So let's see if that works. Wow, so after we actually shaved the plastic from the cabinets and not the metal itself, then these two were able to be slotted in, and the rest of the jigsaw puzzle actually fits now. And so with the dry fit, you just have to examine the places where there's going to be a gap, like here for example, and try and butt up each piece against each other so that they're flush up against each other. And that could be, there could still be some variation from the texture of the wall, but I think that's okay. I need a bit of tape there, otherwise it will fall down again. But apart from that, now we just need the adhesive. How long do you have to press and hold it against the wall?
I don't think hardly any time at all. I think it's ready to stick right now. Number 1.
Okay, number 1. So that first row is completely adhesive to the wall now, and the only strange thing that happens is because this wall seems like it's uneven, maybe the glue is not making it go completely flush, so I'm going to have to go in and push this or something.
You don't want to push on it too much, because you push this down, if it's high here, you push this in, then it's going to come up over here.
Yeah.
That's the problem.
So
Here, we'll hold
Do we let it dry for a bit and then go to the next layer, or just go straight to
Yeah,
the
we
next
can let it
layer?
dry for a bit. Let's see what happens every time I push one corner in, the other one pops out. That's just because the wall's not very flat.
Yeah, I wonder what they do in a hotel or the airport. Wow, that's amazing, and it all fits. Look at that. And so here it is, finally. The tiles are installed. I call them tiles, but they're really sheet. And you know, with a pretty good fit up, you get a really nice result. So this is going to be making a huge statement for the bar area for years to come. I can't wait to see it in all its glory. So at the end of the day, the bar looks really nice. I think the pieces were fitted up really well, and it was a great innovation of Roy to think of actually cutting the plastic hinges of the cabinets rather than trying to cut the metal itself, because you really need to have good shearing tools. It's literally the same as cutting steel, so not a lot of people actually have that kind of equipment in their own houses. So it was just easier to chip away at the little bit of plastic. It hasn't really damaged the cabinet at all. All it does is shaved like literally 1 millimeter off of the hinge, and it hasn't changed its load bearing properties. So at the end of the day, I think the bar looks so much better, enhanced by that piece of crystal titanium. So if you're interested in more projects like that, you can go on to the website of architecturaltitanium.com to look at more projects, trying to understand how the crystals come about. And if you're interested in that for your building or home project, yes, I guess you could get in touch with Gary at architecturaltitanium.com. So big thanks to Roy for all the hard work and help to put that together. And hope this helps you out. And yeah, have a great day and stay safe.